Hey, welcome back to Math with Patrick. Today's August 11th, and we're solving problem number 223 from the Daily Epsilon calendar. And since today's the 11th, the answer should be 11, and we're just trying to figure out what the maximum number of regions in the plane we can get from using 4 lines. And when it does say line, it does mean something that extends infinitely in both directions. It would have to say like line segment if we were doing something that looked like this. Because if I had 4 line segments, I think the only thing I can do is just 2 regions. Um, Maybe I could try drawing a triangle and then my 4th line segment would be here, but I still really only have 2 regions. So it is important to know that when it says lines, they do mean things that extend like infinitely in all directions. And like, I think just intuitively, the right way to do this is to try to get lines that intersect and then try to get lines that aren't parallel to each other. So like, I think this would be a valid solution. Although I want to like kind of intuitively build up that idea by looking at this problem with fewer lines first, just to kind of get a sense of what's happening. Um, I do like doing this kind of strategy of like minimizing the problem or reducing it down to easier concepts to get a better understanding before I hop into something that's a little bit more complicated. So if we were just doing 1 line, I'll do n for the number of lines and r for the number of regions. This is really trivial because we could just pop a line down anywhere and then we divide the region, the plane, in half. There's not much else we could do. It doesn't matter which way our line is going right now because it just splits the plane into 2 regions. Once we have 2 lines, I think we have 2 options to think about. Either we intersect the first line that we already drew, or we don't. And if we try imagining or thinking what happens if we don't intersect, we're creating parallel lines here. And then we have 3 distinct regions in the plane. But of course, it's probably better to intersect our lines because then we're going to have 4 distinct sections or regions rather in our plane. And I don't think it really matters whether our lines are perpendicular or not just yet, because either way, we're just going to get 4 regions. So once we get the 3rd line, we have a little bit more leeway here of like where we place it. We could decide to intersect the existing intersection or not, and then we could decide to be parallel to one of the lines or not. And of course, I think the intuition is that we shouldn't intersect this spot and we shouldn't be parallel to either of the lines, but let's just show what happens if we decided to do that. So let's say I do both wrong things. I intersect this line and I'm also parallel to one of the existing ones. I would be forced to just draw the exact same line over again. And so I would still have 4 regions. If I decided to intersect this point and not be parallel to either of the existing lines, I have 1, 2, 3, 4, 5, 6 different regions. If I decided to be parallel but not intersect the existing intersections, I would have 1, 2, 3, 4, 5, 6 regions again. And then finally, if we try doing neither of those kind of bad things, we would get this setup where I'm not intersecting the existing intersection and it's not parallel to either. And we get 1, 2, 3, 4, 5, 6, 7. So the strategy of not overlapping existing lines and not being parallel to existing lines seems like, at least for now, a good generalization that helps us form kind of the best scenario. So we could like naively do the 4th step and draw some parallel lines. The tic-tac-toe board splits the plane into 9 equal spots. So let's put a 9 here for now as like our best bet so far. This is the best thing that we found. 9 regions, that's more than 7. But whoops, we made a mistake and we made some of our lines parallel when we shouldn't have. So if we try to remove the mistake here and make these lines cross, we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 regions. So it seems like making these lines intersect gives us an additional region. And so 10 is now our best solution that we found. But then it would make sense to finally make these lines intersect as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. And there's not much else we could do because we've done all that we can do. We made sure that we didn't intersect over existing intersections, and then we made sure that all of our lines are mutually non-parallel. So maybe there's more rules that we'd have to consider for this kind of geometry if we got 5, 6, 7 lines perhaps. But at least for now, 11 seems like the best we can do. And then if you like, we could try to find some kind of general pattern here and figure out if there's some kind of closed form representation for like a function. If we have some amount of lines n, can I just plug in that 4 and produce the 11? Maybe let's think back to this scenario where we had 2 lines and we're trying to place the third. So we already know the best scenario is crossing the third line somewhere not here and somewhere not parallel to the other 2. And I'm imagining like this line right here. I could try picking it up and putting it anywhere else on the plane. Maybe I'll try to swing it around this way and draw it like that. But it's essentially the exact same scenario. Then we have that kind of middle ground of getting a parallel line, and that's not what we wanted. So I'm imagining that this line is kind of swinging around. Maybe it's here, which is good. Maybe it's here, which is good. But then there's kind of this intermediate no good spot where it's parallel to one of my existing lines. So basically what's happening is that I have this region, and this region, which I'm able to slice in half. And so I produce 3 new regions based on those. But there's no way for me to reach over and slice this region in half. So at least for here, it seems like adding 3 seems like the best thing I could do because there were only 3 regions that I could cut all at the same time. Actually, if we look backward to the first example from step 1 to step 2, there are only 2 existing regions right now. So of course it would make sense that I could cut those 2 existing regions in half. But then here, it's like there's no one line that can cross all 4 regions here because I don't want to intersect the existing intersection. And so there's going to be, if I pick this one, then I just cannot have that last region right there. And I think this idea extends to all the other steps as well. Like there's probably a perfect spot where I can grab some amount of regions and slice them all in half. And I think for this one, it's probably going to be 4 because I could do like this one, this one, this one, and this one. I could cut them all in half here. So this existing region now has a buddy, as does this one, and this one, and this one. And this line is kind of blocked by my existing intersections here, here, and here, right? I don't want it to intersect any of those ones. We do have something maybe kind of interesting happening if I decide to kind of weave my line between some of my existing points. But it was this region that I intersected, this one, and this one. That's still 4 regions. And so all 4 of those are going to produce another region as well. And so this one will just have a +4 on it. And I'm pretty sure that this is just the pattern where when you place the next line, you will just be able to cross over at most that many regions there. So like this, there's going to be a +5 here. So we'll get 16. And then for the 6th step, we'll get a +6. So that's going to be 22. And just kind of like based on the geometry and based on like not wanting to get parallel lines and not wanting to intersect existing points, this seems like the recursive relationship that I'm seeing. Essentially, we have, let's say a sub 1 is equal to 2. I'm using recursive notation right now. And then to get to the next step, we'll say a sub n plus 1 is equal to some kind of function based on the previous step. So it looks like if n is 2, actually maybe it would make more sense if I do something like this. If n is 2, I'm just adding n to the previous step. So I think we just have some kind of recursive relationship like this, right? So just like testing it out, a sub 4 is equal to a sub 3 plus 4, and that's precisely the pattern that I'm getting down here. So this is my recursive relationship. If I really wanted to, I think I'd be able to write some kind of quadratic equation here because we have constant second differences. But I don't really feel like writing that all out because I feel kind of good enough that I found some kind of relationship here, at least with a recursive equation. So I guess that's a pattern. If you wanted to figure out how many regions you can make with a certain amount of lines, you could follow this recursive pattern, or you could put in the work and find whatever quadratic equation matches this pattern. So I think we're all done. Thanks for watching. This is our answer, this 11 right here, and we are all done. I'll see you tomorrow.